Hi, Dr. B. Shanmuka, Assistant Professor, Department of Mathematics, PSA College, Mandya. In the previous class, we have find out analytic functions of various complex functions and its respective derivatives. Today, that I left this problem in the previous class. So that is show that W is equal to log Z is analytic, hence find f dash Z. So here I use that polar form to find out the derivative and analytic property of this function. W is equal to log Z. You know that a complex variable in polar form is r into e power I theta. Therefore, W is equal to log of r into e power I theta. So, in the complex variable, that polar form is Z is equal to r into e power I theta, that I replace here, and this is by using the property of logarithm. It is log r plus I theta into log e base e is 1. So, therefore, W is equal to log r plus I theta, where r is equal to square root of x squared plus y squared and theta is equal to tan inverse of y by x, that we know that. Then I have to equating real and imaginary part. This is u plus iv, therefore, equating real and imaginary part, we get u is equal to log r and v is equal to theta. V is equal to theta. So, differentiate this with respect to r, dou u by dou r is equal to 1 by r and dou u by dou theta is equal to 0. Differentiation u with respect to r means because it is a function of r and keeping theta as constant, it gives the dou u by dou r is equal to 1 by r. And with respect to theta, no theta terms here, then differentiation with respect to theta r is constant, log r is equal to 0. Similarly, differentiate v with respect to theta, that is with respect to theta it is 1 and v with respect to r it is 0. Then check that the CR equations are satisfied or not. Here just have to take that dou u by dou r is equal to r, that is dou u by dou r is equal to 1 by r into dou v by dou theta. 1 by r is equal to dou u by dou theta. Definitely it is satisfies because dou u by dou theta is equal to 1 and dou u by dou r is equal to 1 by r, LHS is equal to RHS. Therefore, this first CR equation is satisfied and second CR equation is dou u by dou theta is equal to minus r into dou v by dou r. Since dou v by dou r is 0 and 0 into r is also 0, therefore, dou u by dou theta is also 0. Therefore, the real and imaginary part, that is log z, satisfies CR equations. Once it is satisfied CR equations, we can see that the derivative of this function. Log z satisfies CR equations. So, therefore, consider f dash z is equal to e power minus I theta into dou u by dou r plus I into dou v by dou r. Then replace dou u by dou r is equal to e power minus I theta, dou u by dou r is equal to 1 by r plus I into dou u by dou theta, dou u by dou r is equal to 0. So, this gives dou u by, that is dou u by dou r is replaced, it is 1 by r. Here e power minus I theta divided by r. Then by using Milne-Thomson method, replace r by z and theta by 0. Replace Milne-Thomson method says that replace r by z and theta by 0, that gives f dash z is equal to e power minus 0 divided by z, that is 1 by z. So, e power 0 is 1 and this is nothing but d by dz of f of z, that is equal to 1 by z, and f of z is equal to log z. Therefore, d by dz of log z is equal to 1 by z. 1 by z. So, derivative of a complex function log z is equal to 1 by z. Just we compare this with respect to real differential calculus. In the real differential calculus, f of x is equal to log x and its derivative is equal to 1 by x. Just you replace x by z, we can get that a complex function log z is equal to 1 by z. Means the derivative, the concept of the derivative will be applicable here in the complex variable also. So, then I just make that a very simple form of definition. Here the Cauchy-Riemann equation in Cartesian form, the real and imaginary part of an analytic function satisfies Cauchy's Riemann equations at each point. A function f of z is analytic then. So, I give that two derivatives in different forms. One is the derivative is approach form f dash z is equal to dou by dou x plus I into dou by dou x, limit approaches along the x axis. And the second case f dash z is equal to dou by dou y minus I into dou by dou y, limit approaches along the y axis. Because in the complex variable, limit is approaches in any direction. That direction we have that approach we considered here is along the x axis, along the y axis. So, that gives a simple example. This is as similar as that what I have done in the previous examples. The z square, you know that f of x is equal to x square, then it is f dash x is 2x. Here also we can get that same function. Then here in the polar form, the derivative, that limit approaches in two form. One is limit approaches along the radial line, which gives that f dash z is equal to e power minus I theta dou u by dou r plus I into dou u by dou r. And another one is limit approaches along angular path e power minus I theta divided by r into dou u by dou theta minus I into dou u by dou theta. This is the formation, or this is the results for CR equations. Now, construction of analytic function. Construction of analytic function is another topic. Here, construction of an analytic function f of z is equal to u plus iv when real part u or imaginary part v or the sum of real and imaginary part or a difference of real and imaginary parts is given, then we can find out a analytic function, or we can construct that another part of the analytic function in the given form. Example, I take that find the analytic function f of z whose real part is e power 2x x into cos 2i minus y into sin 2i. So, here real part of a complex function, you know that we can have that the real part of a complex function is denoted by u. Real part of a complex function is denoted by u. U is equal to e power 2x into x into cos 2y, x into cos 2y minus y into sin 2y, y into sin 2y. So, u is given and we need to construct analytic function. We need to construct analytic function means then we have to find that the other part v from this function, that is differentiate this with respect to x, differentiate 1 with respect to x, that is dou u by dou x is equal to, now here two terms are there in product, e power 2x and x into cos 2y and minus y into sin 2y. With respect to x means keeping y as constant. When you keeping y as constant means this is a product rule. I am differentiating like this, e power 2x into, now differentiate entire term here, x into cos 2y minus y into sin 2y. Derivative of this means it is cos 2y minus 0. Because derivative of x is 1 and cos 2y is constant, therefore, I taken cos 2y plus this x into cos 2y minus y into sin 2y is constant term, differentiate e power 2x into 2, e power 2x into 2. So, this gives e power 2x into, I take a common factor, that is e power 2x if I take common factor cos 2y plus x into cos 2y minus y into sin 2y. It is 2 times of this, 2 times of this. Cos 2y, e power 2x common factor cos 2y, and e power 2x is common factor 2 into this. So, this is dou u by dou x, we get that from the derivative, and differentiate again 1 with respect to y. 1 with respect to y means you see that here this is a function of x and therefore, this is constant with respect to y, then you keep that, you have to differentiate here dou u by dou y is equal to e power 2x is constant, differentiation of this term x is constant and x into sin 2y into 2. Derivative of cos 2y is minus 2 sin 2y, I am writing here minus sin 2y, differentiate y into sin 2y as product rule. So, differentiate y first and then sin 2y constant, and differentiate cos sin 2y, it is 2 cos 2y, 2 cos 2y. So, here we have obtained dou u by dou x, I can take that this one as 2 and this one as 3. Now, to find the analytic function, we have considered this derivative with respect to x. Consider f dash z is equal to dou u by dou x plus I into dou v by dou x. Here we observe that we have dou u by dou x and dou u by dou y, but dou u by dou x is not obtained from this relation, but we can obtain that dou v by dou x can replace in terms of dou u by dou y by using CR equation. By CR equation, dou v by dou x is equal to minus dou u by dou y. That is, I can take that dou u by dou x is equal to dou v by dou y. This is a CR equation. Now, I replace dou v by dou x by minus dou u by dou y. If I replace that, then I can get that f dash z is equal to dou u by dou x minus I into dou u by dou y, because here real part is given. Suppose other part, that imaginary part is given, means then I can replace dou u by dou x by dou u by dou y. So, it is on the other way also we can find this term. Then here have to replace this by f dash z is equal to dou u by dou x minus I into dou u by dou y. So, from 2 and 3 we have dou u by dou x and dou u by dou y. From equation 2 and 3 we have here dou u by dou x is equal to e power 2x cos 2y plus 2 into e power 2x x cos 2y minus y sin 2y. So, then e power 2x I have taken common factor, then you have to substitute this in the equations. In the equations, this one dou u by dou x and minus I into dou u by dou y, we get this term, it is e power 2x cos 2y plus 2x cos 2y minus 2y sin 2y. So, plus I into e power 2x sin 2y plus 2y cos 2y plus sin 2y. And this is by Milne-Thomson method, replace x by z and y by 0. If you replace this one x by z means e power 2x, cos 2 of 0 is 1, 2z into cos 0 1, that is 0, that is 1 plus 2z, and here y is 0, therefore this term is 0. Again here y is 0, sin 2y it means sin 0 means 0, again 0 into this is also 0, this is also, therefore totally finally I got that e power 2z into 1 plus 2z, e power 2z plus 1 plus 2z, I can get that. Integrate this one. Now integration, we know that integrate, we get 1 by 2 into e power 2z plus 2 into, that is I am using the property that z into integral of e power 2z is e power 2z by 2 minus integral, that derivative of z is 1 and again integral of e power 2z by 2 is e power 2z by 4 plus e. So, after simplification I get that z plus e power 2z plus c. But that integral constant in the complex variable we can add or even we can neglect, it is not a matter, but even if we include, then we will see that how we are going to get in the analytic function property, how we can choose the values of this one. I put this in the form of a note. Take that u plus iv is equal to z is equal to x plus iv and e power 2x e power I2y plus z. That is that w is equal to, we get that is term in the final term, w is equal to z into e power 2z plus c. This you have to see that this is the function, that is f of z is equal to this one. Then definitely f of z is equal to z into e power 2z is analytic function because it satisfies CR equation. By using the condition, this property we obtain z into e power 2z plus c. So, f of z is equal to z into e power 2z plus c. So, this c is, we can add or even we can neglect that, that is not a matter, but x plus iy into 2x plus I2y plus c. So, this is x plus iy into e power 2x into e power I2y. So, e power 2x e power I2y, this you can see that this e power I2y is equal to x plus iy into e power 2x into cos 2y plus I sin 2y, that is plus c. So, this if after multiplication, this term will be taking this form. Then after you multiply that x plus iy and cos 2y plus I sin 2y, we get that e power 2x x cos 2y minus y into sin 2y plus I into y cos 2y plus x into sin 2y, then it is plus c. So, equating real and imaginary part, we get that u is equal to e power 2x x cos 2y minus y sin 2y plus c, and v is equal to e power 2x y cos 2y plus x sin 2y. Taking c is equal to 0 in this case, that means we get u is equal to e power 2x x cos 2y minus y sin 2y, which is real part, and v is equal to e power 2x y cos 2y plus x sin 2y is imaginary part of a required analytic function. So, just the c is an arbitrary constant. If we choose that c is equal to 0, we can get that actual function. What is that? We are given in the form e power 2x x cos 2y minus y sin 2y. So, this is that when real part is given, to construct analytic function, we have followed this method. Then another problem, it is a very important type of problem also. Find the analytic function whose real part is sin 2x divided by cos 2y minus cos 2x. Sin 2x divided by cos hyperbolic 2y, that is just one term, that cos hyperbolic 2y sin 2x divided by cos hyperbolic 2y minus cos 2x. This is actually, you can take that. Again, this is also real part. And this is also real part. Real part u is equal to sin 2x divided by cos hyperbolic 2y minus cos hyperbolic 2y minus cos 2x minus cos 2x. So, now this you can see that as what we did in the previous problem, here also you differentiate with respect to x, that is differentiate with respect to x. Then you see that in the numerator is also function of x, sin 2x is a function of x, and the denominator is also a function of x, that you have to differentiate by u by v method. That is, u by v method says that cos of hyperbolic 2y minus cos 2x, cos of hyperbolic 2y minus cos 2x, then whole squared, cos hyperbolic 2y minus cos 2x, derivative of this is 2 cos 2x minus sin 2x, derivative of cos hyperbolic 2y with respect to x, it is 0, and minus derivative of cos 2x is sin 2x, it is 2 sin 2x, 2 sin 2x. Observe that the derivative with respect to x is completed here. Then you simplify this term, cos hyperbolic 2y minus cos 2x whole square, and the simplification of this is 2 cos 2x cos hyperbolic 2y, 2 cos 2x cos hyperbolic 2y, I just multiply. Then this gives 2 into cos square 2x, and here minus of this, it is again minus 2 cos square 2x, and this gives dou u by dou x will be, dou u by dou x gives 2 cos 2x into cos hyperbolic 2y minus 2 into cos square 2x plus sin squared 2x, it is 1. Therefore, I neglect this term. Cos squared 2x plus sin squared 2x will always 1. Just to dispel, I can take that as 1, and then remaining term I have to write cos hyperbolic 2y minus cos 2x whole square. So, at the end, the u with respect to x gives the 2 cos 2x cos hyperbolic 2y minus 2 divided by cos hyperbolic 2y minus cos 2x whole square. This is one term which I got from the real part given in the problem. Then differentiate 1 with respect to y. Differentiate 1 with respect to y. So, here with respect to y, observe that in the numerator it is a function of x. So, therefore, it is constant. Only you have to see that in the denominator we have a function of y. This I have to take as dou u by dou y is equal to sin 2x is constant, and derivative of this is minus 1 by cos hyperbolic 2y minus cos of 2x whole squared into derivative with respect to this means 2 sin hyperbolic 2y, and x with respect to x means then it is 0. Then I get that this term. So, this gives finally, so minus 2 times of sin 2x sin hyperbolic 2y divided by cos hyperbolic 2y minus cos 2x. This gives minus 2 sin 2x sin hyperbolic 2y divided by cos hyperbolic 2y minus cos 2x whole squared. So, dou u by dou y is equal to this one. Now, this dou u by dou x and dou u by dou y we have. Therefore, consider f dash z is equal to dou u by dou x plus I into dou u by dou x. And observe here we have dou u by dou x and dou u by dou y, but dou u by dou x is not present. Therefore, I have to bring this dou u by dou y or dou u by dou x in this expression just by using CR equation. By CR equation we have dou v by dou x is equal to minus dou u by dou y. So, but dou u by dou x is present in terms of minus dou u by dou y. This I use it in this formula and then use the Milne-Thomson method to get the result, that is f dash z is equal to dou u by dou x is this one 2 cos 2x cos hyperbolic 2y divided by minus 2 cos 2x cos hyperbolic 2y minus 2 divided by cos hyperbolic 2y minus cos 2x whole squared minus I into, if I replace this one I can get that f dash z is equal to dou u by dou x minus I into dou u by dou y. So now I have to take that minus I into dou u by dou y, minus of minus it is plus I into 2 sin 2x sin hyperbolic 2y divided by cos hyperbolic 2y minus cos 2x whole squared. So just you have to see that dou u by dou x is this term and dou u by dou y is that term, that minus of minus will become plus. Now by Milne-Thomson method, replace x by z and y by 0. See that what is that we are going to get. By Milne-Thomson method, replace x by z and y by 0. X by z means it is 2 cos 2z minus 2. 2 cos 2z and cos hyperbolic 0 is also 1. And here sin 2x sin hyperbolic 2y, sin hyperbolic 0 is 0 itself, therefore this term the plus I into 0. Then I can get here cos hyperbolic means it is 1 minus cos 2z whole squared. 1 minus cos 2z whole squared. Here also 1 minus cos 2z whole squared. So 0 by anything is 0. Therefore, f dash z is equal to this term. F dash z is equal to 2. I can take the minus 2 common factor. 1 minus cos 2z divided by 1 minus cos 2z whole squared. So this square and this get cancelled. Minus 2 divided by 1 minus cos 2z. Minus 2 divided by 1 minus cos 2z, just because of just replacing minus 2 I take common factor, then I got that 1 minus cos 2z and 1 minus cos 2z whole squared, and therefore minus 2 divided by 1 minus cos 2z. That is, we know that minus 2 divided by 2 sin squared z. So 2 sin squared z is 1 minus cos 2z, because sin squared z is equal to 1 minus, that is 1 by 2 into 1 minus cos 2z. I use this formula and then 2 get cancelled. This gives minus cosecant squared z. Minus cosecant squared z. Minus cosecant squared z is equal to f dash z. It is minus cosecant squared z. Integrate this with respect to z. Integrate this with respect to z. If I integrate this with respect to z, I can get that f of z is equal to cot z is plus cot z. Then we know that integration of this one. So we have real part of analytic function f of z, and then we construct analytic function, total analytic function f of z is equal to cot z. F of z is equal to cot z, we have obtained that it is a analytic function. Then this is I given here, everything differentiated with respect to y, and CR equation replaced by like this. One is that f dash z is equal to dou u by dou x minus I into dou u by dou y, and this is the term which we finally got that answer. Construct the analytic function whose imaginary part is r minus 1 by r sin theta for r is not equal to 0. Hence find the real part. Hence, find the real part means then first you have to construct analytic function. From there we can find that analytic that is the real part of this imaginary part of analytic function. Then the imaginary part is given here. Imaginary part means then V is equal to R minus 1 by R into sine theta. So, this is imaginary part of analytic function which is given. So, differentiate this with respect to 1 with respect to theta, that is dou V by dou theta is equal to R minus 1 by R into cos theta. Take this one as 2 and again differentiate 1 with respect to R. Differentiate 1 with respect to R means then sin theta is constant with respect to R. Therefore, dou V by dou R is equal to derivative of R with respect to R is minus 1. Derivative of 1 by R with respect to R means minus 1 by R square. It is 1 plus 1 by R square into sin theta. Now, we have derivative for V with respect to theta and V with respect to R is known. Then using these two we have to construct analytic function. Then we know that the derivative of a polar function, the complex function in polar form is f dash z is equal to e power minus I theta into dou u by dou r plus I into dou v by dou r. That is, we have that imaginary part of analytic function and the respective derivatives of that imaginary part is with respect to theta and with respect to r we have, and the derivative of with respect to theta, v with respect to theta, v with respect to r means I can bring that derivative of u with respect to r by using CR equation. So, now I have to replace dou u by dou r. How that replacing dou u by dou r means we know that by CR equation dou u by dou r is equal to 1 by r into dou v by dou theta. Using this by CR equation I got this one dou u by dou r is equal to 1 by r into dou u by dou theta. By this I have to see that I have to replace dou u by dou r by 1 by r into dou u by dou theta. If I replace dou u by dou r by this and dou u by dou theta is present here and use that and then use the Milles-Thomson method, we can get the result. So, using this here I get I can get that f dash z is equal to e power minus I theta into 1 by r into dou v by dou theta plus I into dou v by dou r, dou v by dou r. Now, e power minus I theta 1 by r into dou v by dou theta and plus I into dou v by dou r. Then use this dou v by dou theta and dou v by dou r in this formula, which gives that e power dou v by dou theta is equal to e power minus I theta 1 by r into dou v by dou theta is 1 plus 1 by r into that is cos theta plus I into 1 plus 1 by r square into sin theta. That is dou v by dou theta is r plus 1 by r, r plus 1 by r into cos theta, because sin theta will become cos theta. Then dou v by dou r is 1 plus 1 by r, this is r minus 1 by r, if I am right, r minus 1 by r cos theta. The problem is r minus 1 minus r is sin theta, that is cos theta, right. Differentiation of this gives this one. Now, use that Milne-Thomson method. Milne-Thomson method in polar form says what? By Milne-Thomson method, replace r by z and theta by 0. That gives f dash z is equal to e power minus 0 1 by z into z minus 1 by z into 1 plus I into big 0. Because sin 0 is 0, in that case that imaginary part of this will become 0. This gives that 1 by z into z minus 1 by z, that gives 1 minus 1 by z square. That is f dash z is equal to 1 minus 1 by z square. Integrate this. If I integrate this one, we get that simple term. We get that integration of 1 is z and integration of minus 1 by z square is plus 1 by z. But here I am just taking constant. The arbitrary integral constant is I am choosing IC because that imaginary part of an analytic function is given. Then we can easily eliminate IC by taking suitable value, and so that actual imaginary part can be obtained. So, f of z is obtained. This is the analytic function. Hence, find the real part of this analytic function. Means, as usual, I have to take that here. I have to use that r into e power I theta plus 1 by r into e power I theta plus IC to find real part. Let us consider z is equal to r into e power I theta in f of z is equal to z plus 1 by z. That gives r into cos theta plus I sin theta and plus 1 by r into, because e power I theta is this one, means by de Moivre's theorem you can know that cos theta minus I sin theta plus IC. This you simplify, find out r plus 1 by r is cos theta plus I into r 1 minus r into sin theta plus IC. So, here r plus 1 by r coefficient is cos theta, it is r, then 1 by r again here coefficient is cos theta, it is r plus 1 by r cos theta plus I into, that is coefficient is r and then I coefficient is minus 1 by r and sin theta. This gives r plus 1 by r cos theta plus I into r minus 1 by r sin theta plus C. Equating real and imaginary part of this function, that is u plus iv, which gives that u is equal to r plus 1 by r cos theta and v is equal to r minus 1 by r sin theta plus C. Just observe here u is a real part of that analytic function f of z and v is the given imaginary part, but this C is just because of integral constant. To get that actual imaginary part, I choose that taking C is equal to 0, it is an integral constant, v is equal to r minus 1 by r into sin theta. This is actual imaginary part given in the problem, r minus 1 by r sin theta, and the corresponding real part of this analytic function is r plus 1 by r cos theta. That is the required answer for this problem. Construct the analytic function whose imaginary part is given and then that is find the real part. This is the answer for this problem, and even I use this derivative on RHS of this, we get that term. Then finally I got that z plus 1 by z IC, this we get equating real part. And now so we have understood the concept of that. Was suppose if real part is given, then we can construct analytic function, respectively we can find out the imaginary part of that complex function. This is similar in both polar form and Cartesian form. So when polar form gives, then we have to use that. Generally we use the formula f dash z is equal to e power minus I theta dou u by dou r plus dou u by dou r. In the Cartesian form, generally we use that f dash z is equal to dou u by dou x plus I into dou u by dou x. So other formula, the other part of the CR equation formula also we can use and then get the same result. Now suppose the problem given in this form, then we can also find out construct analytic function. Find an analytic function f of z as a function of z, given that sum of real and imaginary part is x cube minus y cube plus 3xy into x minus iy. So here that sum of real and imaginary part of the analytic function is given, means sum of real part is real and imaginary part is u plus v. So u plus v is given, therefore u plus v is equal to x cube minus y cube plus 3xy into x minus y. So in the given problem, we have that sum of real and imaginary part of an analytic function f of z is given. Analytic part of f of function is given. So therefore x cube minus y cube 3xy into x minus y. Now differentiate this with respect to x. Differentiate this with respect to x means I can get the dou u by dou x plus dou v by dou x. Derivative with respect to x keeping y as constant, that gives 3x squared minus 0. The derivative of y with respect to x is 0, and then here plus we have that two terms product rule. Therefore I can get that differentiate this with respect to x, it is 3y into x minus y, and differentiation of this 3xy into one of the derivative of this means it is 1 minus 0. This gives 3x squared plus 3y into x minus y plus 3xy. That is dou u by dou x plus dou v by dou x. You keep this one as 2. Keep this one as 2. Now differentiate 1 with respect to y. This is differentiate 1 with respect to x. That gives dou u by dou y plus dou v by dou y is equal to 3x squared, that x cube is 0 minus 3y squared, and here that is plus 3x into x minus y plus 3xy into minus 1. That is, this is differentiate this with respect to y and keep this as constant, and plus that is keep as constant and differentiate this with respect to y. X with respect to y is 0 and y with respect to y is minus 1, that I have written here. So therefore dou u by dou y plus dou v by dou y is equal to minus 3y squared minus 3xy plus 3x into x minus 1. You take this one as 3. Now in the previous problems we observed that to construct analytic function have that two formula. One is f dash z. We have that two formula. One is f dash z is equal to dou u by dou x plus I into dou u by dou x. Or I can use f dash z is equal to dou u by dou y, that is dou v by dou y minus I into dou u by dou x. So in the beginning of today's class I give that Cauchy-Riemann equations theorem, and then how we get that. This is with the limit approaches along the x-axis, this is limit which approaches along the y-axis. So, either I have to see that I want to find out dou u by dou x and dou u by dou x, so that I can substitute here by using Milnor-Thomson method, I can get that result. Therefore, I have to use this one. Now, from 2 and 3, either you can find out with respect to x or with respect to y. So, now I change this one by using CR equation. By CR equation, dou u by dou x is equal to dou u by dou y, and dou u by dou y is equal to minus dou v by dou x. I use this result here. So, dou v by dou y is replaced by dou u by dou x, and dou u by dou y is replaced by minus dou v by dou x. So, therefore, I have to use this result here, that is I can get that minus dou v by dou x plus dou u by dou x is equal to minus 3y squared plus 3x into x minus y minus 3xy. You take this one as the common term. I wrote this by after replacing this one, I bring this as this is 2 and you call this one as 4. Adding 2 and 4 and subtracting 2 and 4, we can get that result. What is that result? Adding, we get that 2 times of dou u by dou x is equal to, if I am adding this one, I can get that 3x squared minus 3y squared. Then it is minus 3xy plus 3xy get cancelled, plus 3x into x minus y plus 3y into x minus y. So, this gives 3x squared minus 3y squared plus 3 into x minus y into x plus y. So, I got that this simplification, it gives that 3x squared minus 3y squared, x minus y into x plus y is x squared minus y squared. X squared minus y squared means plus 3x squared minus 3y squared. So, this gives 6x squared minus 6y squared. 6x squared minus 6y squared means dou u by dou x is equal to 3x squared minus 3y squared. Call this one as 5. Now, adding this we get this one, subtract this, I get that 2 dou v by dou x, that gives 3x squared plus 3y squared. If I am subtract this, I am going to get it as 6y, and here I can get that plus 3y x minus y minus 3x x minus y plus 6xy plus 6xy. Simplify this by using the simple 3x squared plus 3y squared plus here x minus y is common factor, 3 into y minus x plus 6xy. Take that, here I am using x minus y is common factor, I get that 3y minus this. Now, this gives 3x squared plus 3y squared plus, just I am taking that minus 3 into x minus y whole squared. So, take that x common factor, this one x minus common factor, this will become x minus, otherwise you take minus common factor here, this will become y minus x, therefore I can get that x minus y squared plus 6xy. After simplification, I can get the 3x squared get cancelled, 3y squared get cancelled, minus of 6xy, that is plus 12xy. Here I get that, if you expand this one, 3x squared, 3y squared get cancelled, here also I can get that minus 2xy means it is plus 6xy plus 12xy, and 2 times of dou v by dou x is equal to 12xy, Therefore, I can get that dou v by dou x is equal to 6xy. This is 6. We can get that result. From this, you have to observe, I can find that analytic function for this case. Consider f dash z is equal to dou u by dou x plus I into dou v by dou x. This is as usual that derivative function. Use this one. This is 3x squared minus 3y squared plus I into 6xy. So, using this here, I can get the 3x squared minus 3y squared plus I into 6xy. Then by Milne-Thomson method, x by z and y by 0. This gives 3z squared minus 0 plus I into 0, that is 3z squared. F dash z is equal to 3z squared. F dash z is equal to 3z squared means integrate this. If I integrate, I can get that. If you integrate this function, we can get that f of z is equal to 3 into z cube divided by 3. Therefore, 3 get cancelled. If you want, you can write that c. Otherwise, you will neglect that c also. As usual, in the previous problem, you have observed that this one. F of z is equal to z cube is that final answer, which is the analytic function, for the given the sum of real and imaginary part of this analytic function. I find out totally that analytic function f of z is equal to z cube. This is today's. I solved that few problems which are very useful to understand that construction of analytic function by using CR equations and Milne-Thomson method. Therefore, I have to take up that some more problems in the next class. ಇನ್ನೂ ಇತ್ತು.